Hi, everyone. Thank you so much for joining our webinar. We really appreciate your attendance and continued support for Intrepid. Our host today is Matt Snyder. He is a field application engineer here at Intrepid. If anyone has any questions throughout the presentation, feel free to use the Q&A feature or the chat, and we'll try to answer as many of them as we can before we finish. This webinar is being recorded, and we'll be posting the video on all of our socials as well as sharing the presentation slides. So make sure you're following us on all of our accounts so you can access those. Thank you all again, and without further ado, here is Matt.
Okay, well, I appreciate everybody joining. Thank you. Like Jordan said, my name's Matt. Today's webinar will be about automotive network gateways, what those mean, why we talk about them so much here at Intrepid, why they're so important, seemingly to just about all of our customers, and what kind of features we produce in our software and our hardware that can kind of trivialize the process of what used to be a pretty tedious and time-consuming task, albeit important task. So that will be the focus today. Let's see if I can figure out how to change slides here. There we go. So that's my name. A small little bit about me. I'm a field applications engineer at Intrepid. I started out in our tech support department. So most of what I know about this stuff comes from working directly with customers and helping solve their problems. And a lot of them involve gateways, testing different modules in vehicles, and that involves moving traffic around to different networks that are sometimes the same, sometimes very different. Sometimes we're doing this to accommodate tooling, et cetera. I have a lot of experience working with those type of problems, so I'm going to talk a little bit about that today. If you'd like to reach out to me, by all means, send me an email directly. You could also drop me your contact info here in the chat or whatever you'd like, and I'd be happy to talk directly and not publicly too if you can't really share too many details about what you're doing specifically. You can also add me on LinkedIn. I love LinkedIn. It's probably the only social media I really use. So feel free to add me on there and network there. A small bit about the company I represent. So I think a lot of this would be worthless without understanding why we consider gateways one of our core competencies at Intrepid Control Systems. We've been doing this stuff for 29 years. We have been a product-focused company for the majority of our existence. What that means is, well, we build products, right? We build hardware and software tools that help engineers do their jobs. I suppose you could contrast this with a service-focused company, which is more focused on engineering services. We absolutely do offer engineering services, but historically, we've been a product-focused company. Offices all around the world. I know that we probably have attendees from all over the world too. And I appreciate you joining us at this time, but just know that in your time zone, we probably also have some support resources that you can use and abuse. And we kind of pride ourselves at Intrepid on providing support to everybody that uses our products. And we invest a lot in newer technologies. So if you think that you're being presented with especially a new physical medium for low voltage communication in vehicles, if you think that it's new and tooling might be difficult and you can't maybe find anything by doing a Google search, reach out to us because we very well may be working on something that you might need. It's just maybe not out there yet because it's so new. That's a pretty important and big part of our business. Automotive Ethernet, CAN-FD, these are core competencies of Intrepid. We do a lot of work in the cybersecurity and the autonomy space, especially with stuff like ADAS testing. So gateways, I've said that 100 times. Let's actually talk about what they are. Automotive gateways can really be boiled down to the concept of moving data from one network to another. What data means is really the big variable in there, but it's typically moving data from one network to another. Same or different physical media. So, going from CAN to CAN-FD is a pretty common gateway use case that we see, but going from CAN to Ethernet, CAN-FD to Ethernet, LIN to Ethernet, how about taking Ethernet signals that are from newer, maybe drive units that we're working with today and moving them over to CAN or CAN-FD so that we can use older tools or older, even projects that are using older tools. Maybe we don't want to necessarily reinvent the wheel to work with our new equipment, or we don't want to commission like bespoke software engineering to handle that kind of challenge. Gateways can help kind of solve that problem, especially early on before you have the infrastructure or the tools to work directly with the newer technologies that you're faced with. So we are approached all the time for many different types of gateways. It's difficult to kind of describe all the different types of gateways without going into every single different type of protocol that we support. So the type of gateways that we see with CAN, which is a multi-drop network type, is very different than Ethernet, which is a switched network topology, and typically a ring, but there's a few different layouts that we usually see. Just the very way that we tap those is different between the two. So it's kind of important to remember that. But there are two kind of main configurations that we see for gateways. The first one would be intercepting messages, or signals, or intercepting traffic, really. This is where we intercept bidirectional messages, and then this gives us the ability to alter or select specific messages that we want to pass through. So filter opportunities, modification opportunities. And then the other configuration we usually see is a tap, where the bidirectional traffic or even a single direction of traffic can be altered or selected or passed through with a direct copy being sent down to the instrumentation that's attached to the gateway. So this is more where we see traffic kind of being copied down so that we can sample it without necessarily breaking any links or any wires in our setup. So it really depends on how intrusive we need to be. And like I said, the physical media that we are using is going to determine how intrusive we need to be. So gateways can move entire networks, messages, signals, or a mix of these. You can have many different gateways in your setup, some that are messaging or moving signals as they come in, and maybe some that are triggered off of certain events that might just move signals into new messages. Maybe you need to completely repack messages with new signals. Gateways can kind of do all of these types of things. It's just traditionally, it was a difficult task because you had to kind of script this out one by one and account for every different type of message. It was very tedious. And if you didn't kind of do it properly, you could run into timing issues, and it was just it was a tall ask. And that's why when I kind of came up at Intrepid in the support department, it was a huge thing that we were contacted for all the time. I need to move this data over to this network, or I just need to kind of block this traffic from hitting my ECU so that I could do this kind of testing, or I need to change this value so that the ECU so I can judge maybe how the ECU reacts to some strange anomalous sensor value. Gateways can enable this type of testing. So the main tool then that we're going to talk about is the Gateway Builder tool. There's quite a few different ways of building gateways in our software. And this is a tool that's included in the Vehicle Spy 3 Enterprise software. So what is that? Intrepid offers it's a protocol analyzer called Vehicle Spy 3. The nice thing about Vehicle Spy 3 is when you buy a license for it, you get access to all of those different types of networks that your hardware supports. So let's say you've got the device that you see here, the neoVI Red 2. That device doesn't just support 1 or 2 CAN channels. It could support up to 8 CAN channels, 2 LIN channels, 4-wire, Ethernet, a bunch of different types of things. And if you've got our software, you've got access to all of those different types of networks. So instead of kind of gating by license the type of networks you can work with, we only have a few ways that you can buy the software. It's a lot simpler. So the Gateway Builder tool is included in Vehicle Spy 3 Enterprise. So if you already have a license for that, or maybe you've got a pro license and this tool is something that you think might make a difference for you, it can be as easy as just maybe upgrading to Enterprise. Or you might already have it if you're already working with that software. So what is the Gateway Builder then? Well, it's a GUI that trivializes creating gateways, right? So historically, we used to make gateways in function blocks or just by writing code, right? You could do gateways in C, C#, C++. But we found that it was very time consuming, and even to do small like inconsequential gateways, I suppose, where you're really only moving 1 or 2 signals. It seems like it would be pretty, it wouldn't be that intense on your hardware, but it was a lot of code because there's a lot of parts to message frames. And especially if you're moving to different networks, there's a lot that could account for. And then because there's so many differences between the protocols, A lot of times you've got to get crafty with kind of how you're creating the frames that you're trying to send out onto your gateway network, excuse me. So it tended to be very time consuming and very tedious and very expensive when you look at it from a time perspective. The Gateway Builder tool, another nice feature of it, though, is it's usable with your PC or embedded into your Intrepid hardware. So that means that if you're looking to view traffic live, you want to use your computer to use our protocol analyzer to use the messages editor or to use the messages feature to view the traffic as you're doing these things. That's fine. That's one use case for this, but you could also build these gateways and embed them into our hardware. So when performance is critical and timing is critical, and you want to kind of get the most oomph out of your hardware, you can literally build a gateway in a minute and then send it down to your hardware, and then you could throw the standalone data logger like the Red 2 into your backpack, and then you could be on your way. The gateway will stay on your hardware through power cycles. You could go vehicle to vehicle. You could go location to location. You could even put it in the mail for somebody. That's a nice thing about, we call it the core mini console on our hardware, but it hosts scripts of all different types from our software, and gateways would be one type of setup file that you could send down and host. So that really gets a lot of performance. There's nothing like running a setup, quote, right on the rails of the hardware. There's nothing quite like that when it comes to performance. So that's kind of the need. And a lot of times that's critical, especially with Ethernet gateways, where it's a lot of traffic, a lot of potential bandwidth, very fast. It can be pretty darn important to get a lot of performance out of your hardware. So running the gateways directly on it is a huge benefit. So gateways, how about why? Well, let's talk about what purpose gateways actually serve. Like I said, I'd say the main purpose of gateways is data routing. So the gateway tools enable seamless interconnectivity. So what I mean by that is allowing ECU data to be distributed across many different types of networks. I mean, different physical types of networks. So not just CAN to CAN, but CAN to automotive Ethernet and bidirectional. This feature can be very important in prototyping vehicle, prototype, or a lot of people are very familiar with lab cars, but prototype vehicle integration. So as new components need to be integrated for testing into our benches or our lab cars, you can bring all of these ECUs together very quickly without necessarily needing tools that, hey, they might not even exist yet if it's a newer communication protocol. Like we recently demoed a 10-base T1S to regular Ethernet gateway. You know, I don't think that you're going to find many tools on if you Google or look through our some other types of protocol analyzers, but Gateway Builder's already, or Gateways and Vehicle Spy 3 is already achieving or accomplishing those tasks. So that's data routing. That's a huge piece of why we gateway. Filtering messages, also another important task. So the Gateway Builder brings the capability to selectively filter messages. So this allows you to block specific data from being transferred across the network. Talk about loss of comm testing, right? It's invaluable for testing vehicle software and diagnostic systems under conditions where data has to be absent. So historically, cutting the cord, is one way of doing it, but that causes all sorts of other problems, and that's expensive. Gateways allow you to, at a software level, block that kind of traffic. So this provides invaluable insights into system resilience to different types of, basically loss of comm, loss of signals, maybe signals suddenly not being present that are expected to be there. This is a huge use case for gateways. Beyond just blocking data, modifying data is probably one of the biggest ones as well. So signal modification mapping across different network types, that's always been a challenge. And we always, we have a history of helping our customers solve these types of problems by writing out function block scripts that look for specific signals and overwrite their values or route them to different networks. The Gateway Builder trivializes that past or that use case. So think about fault injection. So maybe you need to send a value that you can't easily fake, right? Like maybe you want to send a false temperature value to your oil pump. Like you want to send it at, say it's 3,000 degrees, something absurd. You could do that and then see how your ECU reacts to that. So, this can be a good way to test how your vehicle reacts to damage in the vehicle. So, let's say a cord is chewed, or let's say there's an accident. Do the safety critical systems continue to function? What happens if this module goes down, but this module doesn't go down? What happens if this module goes down, but it's still communicating? It's just sending bad values. This is, the foundations of fault injection, and gateways provide a really easy platform for setting up these types of setups. So if, let's say you're just trying to modify that temperature, I could have a gateway using the gateway builder set up to change that signal or block that signal in a couple minutes. And I could have it running, on the hardware or on my PC. No extra effort really between the two. It's something that I remember, just, 5-6 years ago, spending hours and hours and hours setting up gateways that just are maybe modifying 2 or 3 signals. And if the engineer wanted a lot of control over what that, that value was at any given time, it was a lot of work. This really trivializes that. What other purposes do gateways serve? Well, it provides a stop kind of in the network logic for compute and logic. So Vehicle SPI 3 has all sorts of mathematical and logical functions that you can introduce into the gateway to enhance the signal processing capabilities of your setup. So things like checksum calculations, adding in new messages. Maybe you just want a gateway. Maybe you want to gateway one message and you want it to be triggered off of another message, but they're not really the same. Or maybe they're even on different networks. Gateways allow for that type of use case. Maybe you want to calculate the signal value while it's maybe halfway through its journey from one ECU to another. Maybe it itself in the vehicle is going through a gateway and you want to intercept that after it comes out of the gateway and before it goes into the gateway to kind of see what's going on. Maybe you want to introduce your own checksums. Maybe you want to move data from one network to another, but that would then require a checksum to be recalculated. The gateway builder also will do that for you automatically in most cases. It really depends on the type of checksum. But in a traditional script type gateway, just recalculating the checksum sometimes wasn't even possible. Sometimes we had to bring in C code to do this. Sometimes we had to, access a DLL because we had no way of building these functions into the software automatically. These were all difficult use cases that, well, I appreciated early on because it certainly helped me learn, but the gateway builder makes it so with just a couple clicks of a mouse, you could be recalculating checksums automatically at different steps along the way. And then this includes adding in new messages and then maybe calculating a new checksum that you define on those messages. All of this compute and logic is introduced once you're using the gateway builder. Another big purpose of gateways would be using them embedded. So like I said, when performance and timing is critical. So especially after completing development, your prototype gateway can be integrated smoothly to run on our hardware tool chain, ensuring efficiency and timely data handling. And this is across multiple physical media. So if reliable and prompt data processing is kind of the crux of the use case that you're working with, the ability to run it on the hardware is second to none. The timing precision that you get that way without investing tenfold in terms of dollars into your hardware setup. This is a really easy way to set up a performant gateway. Last but not least, we see a growing use case of our gateways in SDV prototype validations. So as the software-defined vehicle kind of takes shape and form, and it looks a little different everywhere, but as that validation process begins, gateways, especially because we're seeing a lot of new physical media, they're enabling the testing of these different types of ECUs and the testing of their communication in a very easy way. In handling complex data scenarios, the ability to kind of take all of those things that we just talked about, so lots of different compute logics, the ability to control messages, the ability to talk to different types, that is really what is needed for the software-defined vehicle, as we see a lot of traditional use cases kind of move to different types of physical media. So you're already learning new stuff, right? You're already learning new transport layers. You're already learning new protocols. It doesn't need to be difficult to connect all of those. It can be very easy. You don't need to overburden yourself with, well, I also have to learn a scripting language, or I also have to learn, how to use all these different handles in the software so I can build this gateway. Oh, and then I also have to figure out how to make it efficient enough to run on the hardware. So the gateway builder does all of that for you. So you can just focus on maybe learning what 10-base T1S is, or learning what automotive Ethernet is, and not necessarily have to focus on just being able to use the software because the use case that you have is so complicated. So gateways can make engineers that are transitioning into the SDV or just starting into the SDV prototype validation roles a lot easier. So let's talk about the gateway builder. Before we do, I want to make sure that it's clear that the gateway builder for Vehicle Spy exists in the enterprise version of our software. So like I said, we don't have a lot of different types of software you can buy. We have Vehicle Spy 3 software that gets you a whole bunch. But we do, for people that have really simple use cases, we've got some kind of pared down versions of the software that are a little bit less expensive or a little bit more inexpensive, like the Pro version and the Basics version. But most of our customers exist in the enterprise version. That's where all of our new features and all of our kind of more complex features go. If they're automotive Ethernet involved, they're definitely an enterprise. But the gateway builder is it could be a piece of software kind of standing on its own. So it's in the enterprise version. If you have some of these other versions, like I said, it can be a pretty easy jump to enterprise if you haven't already. By all means, reach out to us if you want to talk about that. But I want to make sure that you know that if let's say you already have Vehicle Spy, if you think that you're going to open this up and immediately use the gateway builder, just make sure you have the enterprise version. And if you're not sure what version you have, reach out to our support department, which I'll be providing contact information for at the end of this. So function block gateways, I think we have probably heard me talk about these enough in the last half hour. This is kind of what they look like. So this is a very simple function block gateway. These type of gateways, this is how I learned gateways. This one in particular is J1939, just a signal gateway. It's, like I said, it's very simple. It's not doing a lot of, signal modification, a lot of those core use cases that we talked about. This is just gatewaying certain signals from one message to another. But this took time, line by line, going through and making sure that I accounted for all of the different kind of corner cases that can happen if signals come in different orders. This isn't doing anything like recalculating checksums or forming new messages on different physical networks like Ethernet. We could do all of those types of things with Gateway Builder, and it's still easier than going line by line and doing function block gateways. I don't want to disparage function block gateways. If you're working in the Pro version, you might have been doing this for years, and you might be very handy with this, and that's fine. But the Gateway Builder is here to save time. So it will build all of this for you with just a couple clicks of the mouse. That's kind of the purpose. Gateway Builder is built by basically a concept of inputs to outputs. So here's an image of what the software looks like. There's a couple assumptions that are made here. So we are looking at database messages on the input side, and database messages are on the output side as well. So in the screenshot here, you see on this side, I've got CAN, and on this side, I've got Ethernet. And we're just showing objects to you as messages or signals. They're seen as one and the same, despite the obvious differences in their physical natures. What else do you get then by just kind of looking at the main Gateway Builder view? You get multiple gateways. So if you notice up top here, it says Gateway 1. Well, we can build many different gateways. We can enable them and disable them. We only have one enabled at a time, but we can script them against each other. So maybe you want to build a function block that's watching for a certain condition in the car, and then you want to turn your gateway on. Very easy to do. And then let's say you want to, switch between 3 or 4 because you want to build a bunch of different tests into your maybe your hill or sill. You can build a bunch of different gateways and then trigger them on the software level and create an automated series of tests. So after that, we make the connection. You simply drag inputs. So these can be message objects or signal objects or entire networks, but you don't have to drag the networks. More on that in a second. You drag them into the center, and for each individual message or signal, you'll be greeted with the setup panel down below. And I'm going to show you this in the software in just a second here. And then you get access to the gateway methods, which is forward, map, and trigger. We'll go through those in a second as well. And you also get a platform for adding in those compute formulas that I mentioned. And then many other types of customization that can be added to each individual PC or gateway. So one of the main types of gateways that we see is gatewaying entire networks. So and we're talking dissimilar networks, right? So CAN to Ethernet, CAN FD to Ethernet, back and forth. We can do this with the click of a button. So both directions need to be set up. So if you want it to go both ways, if it's got to be bi-directional, 2 clicks of a button. But everything is passed through the target network unchanged. So you don't have to account for all the individual types of signals, the individual types of frames, nothing like that. We can just gateway the entire network, and Vehicle Spy 3 will take care of everything that needs to be taken care of so that that network can be transmitted onto your output network. You also get access at the bottom to the exclusion window, which is a really easy way then to add basically filters into your gateway. So if you want to exclude specific traffic or filter specific signals, maybe you want to gateway a message that has a whole bunch of signals, but for performance reasons, you only want to take maybe 1 or 2 of those signals. Well, you could even do a message gateway and exclude certain signals out of it. And then on the output network, you'll get a message that has just the signals that you wanted to gateway. So don't forget, for best performance or when timing is extra critical, you can run this gateway directly on the hardware. That's the core mini console. So if maybe you just need something that automatically gateways CAN 1 to CAN 2, that is 1 click of a button, and then you can have it running on your hardware for the next 5 years. When we're doing network gateways, we also get an opportunity to change the protocol along the way. So again, in function blocks, this was challenging. So taking a CAN frame and putting it in an Ethernet frame, that was a tall ask. You have to it's a big shift over 40 plus bytes to get it into the right spot, and then decoding it meant looking into a much larger area. This was many lines in a function block gateway. Here we could just switch this as we need. I will mention that obviously protocol rules still apply. So if you've got a CAN FD frame that's 25 bytes, just some random amount, and you're just gating it over to CAN, well, we're going to truncate it down to 8 bytes because classical CAN supports 8 bytes. So if you do that, and I'll show you this, we will give you a little warning so you know that we're taking action like that, like we're truncating something, or maybe the message on the other side doesn't have the same scaling setup, or maybe you're taking and let's say a 2 byte signal and you're putting it over onto a message that only has a 1 byte signal in it. We'll allow you to do that so that you can, maybe that is still just one long analog value and you don't actually need it that granular. That's fine, you can do that, but we'll give you a little warning just so you know that something like that's happening. But regardless of that, maybe you are just doing CAN to CAN FD, you've got enough room, but you want a CAN FD tool to accept this information down the line. Just switching it over to CAN FD is very easy then, right? 1 click of a button. And as we switch protocols, by the way, if you see my screenshot here, I do want to mention it's all CAN because we've got CAN selected. When I select, say, linen here, this is going to change. When I select Ethernet, which has a lot more protocols that we can support, this is going to change as well. Okay, so let's talk about message gateways. Let me see how I'm doing on time. We're doing well. So message gateways, another type of gateways. Remember, the first type was network type gateways. So message gateways, to do those, you select your input message and drag it to the center, just like you do any other objects. You can now choose your method for, or your action, I suppose, that you want to take on that particular object. So if you want to forward it, that means sending that message as is, unchanged, to the output network. If you want to map it, it means it takes that message and it maps it to a selected message on the output network. So it's not just going to take that message as is. Maybe you want to take that message and maybe it's on RBID 5FD and you want to transmit it out on RBID 100. You can then map one message to another. And then you could also use the trigger action, which is it's just that. It's a trigger action for the receive or changing of data on one message, and then that triggers the transmitting of another message. And maybe something that needs to be calculated is on that message you're being sent. Maybe not. Maybe it's just a different message. Who knows? Trigger action, that's another type for message gateways. So this is what it looks like to forward that. So we're gonna do this in vSpy too. So if you want to see how this looks, I'm gonna do that after I explain these concepts. But forwarding a message, it looks just like this. So if you select forward, you'll see right up at the top here, the message that I dragged in is represented here. And then over on the right-hand side, it's just going to ask for the network, right? So it doesn't need to know what message or what signal because we're just forwarding it. We're unchanging it. We're taking it and it's going to show up like it did on one network on the other. So if it's, that message on 5FD on CAN, it's going to show up as 5FD on CAN on the output network, if it's CAN. Mapping, the action's the same, but the only difference here is you've got your input message coming in here, and then you specifically are dragging an output message into the field here. So instead of, it just forwarding it along as is, it's asking you specifically which message you want to map it to, because it's assuming that you want to change something. Otherwise, you would probably just be forwarding, right? So that's what this does, maps the message to a specified network. And then triggering a message. So again, we drag our object into the center here. It shows up right here underneath message. We are still going to then kind of pick a message, but this can be a different message or it could be the same type of message, but we're assuming that something is going to happen. So a lot of times here, we are recalculating some sort of value before we're sending a message out or a checksum or something along those lines. That's what this option or this action is going to primarily be used for. All right, let's talk output triggers then. So we have different ways of controlling when the messages are mapped, right? So these were our input options. We can choose to trigger. We can choose to trigger our input option, these input options, based on these output triggers right here. So the receive, change, and condition. So with receive, it's whenever it happens on the input network, it happens on the output network. So if a message appears on one, it appears on the other. And that can, like I said, that can still be forwarding or mapping. It doesn't have to be as is, but it means that that's going to essentially be our trigger for gateway, and that's going to be when we do it. So we can also do it on change, which is transmits the message whenever the data changes. So let's say we're moving one signal to the other, but we don't want to necessarily change it at the same rate that it's being sampled on the input network. We might transmit the message whenever it's changing because that's what we're looking for. So maybe we're looking for a state encoded signal on another network. And we don't care when, for example, the car is staying in park, but we need to know immediately when it goes into drive or neutral or leaves park. That would be one way to, this would be one way to do that. So we could select our output trigger as the changing of that Prindle state. And then we can also do condition, which transmits the message whenever your expression or formula evaluates as true. So if you've ever used our expression editor or the formula editor in any other parts of the software, this is the same thing. So you can take a signal and you can choose to trigger it on a condition when, let's say, you don't want a gateway until your key on. Maybe that's your trigger. Or maybe you don't want a gateway until a signal reaches a certain value. So if we go back to like oil temperature, maybe you want to wait until that kind of needle in a haystack event occurs and the oil pressure evaluates as way higher than it can actually be. You might set up a gateway to watch for that signal change to go over a certain amount, and then we could use that as our output trigger, and that could send the message maybe to like a network that is meant for data monitoring, or it might trigger a diagnostic call. Maybe you want to read a DID when that happens, so you can see if something else that might be sampling that temperature is reading the same thing. These are all different types of ways that we could trigger our input network actions. So let's talk signal gateways next. These work very similarly to message gateways. So you select your input signals and drag them to the center, just like messages. So you can then choose the message, choose the method or the action, which is not, it's basically the same way as messages, but not quite. So if you forward it, this sends the signal as is to the defined message on the output network. So let's say you grab one message or one signal on one message on CAN, and that's all you're dragging. Well, obviously you can't send a signal without the message, right? That's the transport part of your data frame. We'll still take that automatically, but we'll just transmit, or we'll just gateway the individual signal that you did. So there's kind of a way to do this in selective message filtering, but signal filtering gives you, signal gatewaying gives you a really easy way to forward signals from one network to another. Mapping, same type of deal. Maps a signal to a specified signal on a specified message on the network. So if you want to take one signal and move it into another signal field on a different message on that network, that's what this is for. So instead of it building that message frame automatically, it's going to ask you to define where that signal is going. So you would build that, you would create a message for that in the receive section of the messages editor, which I'll show you in just a moment when we open up the software. And then trigger, same deal. You can use this to trigger the output message that contains your signal that you're looking to gateway. One big note that I want to make about signal gateways. So in the gateway builder tool, signal gateways override message gateways. So to give you kind of an example of what I mean by that, let's say you've got a message to be sent, yet the signal still needs to be recalculated. So the message doesn't send until after that takes place, because that signal recalculation takes precedence over the message gateway. So you can kind of think of this as overlaying the signal over the message. And this is done on purpose as a way to control when certain things need to happen before that message is sent, to make sure that we're not just sending what we call stale data. A couple other features I'll touch on briefly in the Gateway Builder before we get into the software and do this. Attempt match, we'll try to attempt matching your message automatically to messages that have the same name on the output network. So if you're, let's say you load a DBC in for CAN, and then you're just trying to move data from CAN 1 to CAN 2, well, you can load that DBC on the other, and it will automatically try to attempt to match the messages as they come across, so that decoding's easier. Works really well, saves a lot of time. Allow duplicates. This allows two instances of messages or signals to exist simultaneously. And yeah, this can cause problems if you're not doing this on purpose. But normally the first one is pre-selected, and then you can swap between the two. But allow duplicates will allow both of them to go on the networks. And maybe you need that because let's say you've got, well, in CAN, it's multi-drop, right? So everybody's talking. So maybe you want to talk, maybe you want to see what happens when one ECU is getting the same message, but from two different sources, when that shouldn't necessarily be happening. This would be one way to kind of allow for something like that to happen, which is not something that's usually possible in the software you're using. This is a big one that I want to talk about because this is a new one. So let's say you're working with AUTOSAR, specifically AUTOSAR PDUs, and you've got a bunch of older tools or legacy tooling, right, that does not support AUTOSAR. And changing those tools, especially if they're big pieces of hardware like dynos, battery testers, big test stands, you don't want to just throw those away. They were a lot of money. So we have a new feature. Right now it's a standalone feature, but we're building it into Vehicle Spy 3 Enterprise. So those that are using Gateway Builder will eventually get access to this as well. But we now have a utility that allows you to easily take AUTOSAR PDUs from your ARXML and gateway them to CAN, CAN-FD, or Ethernet frames with ease. And this is something that I don't know that there's another solution on the market for this. If there are, I'd be curious to know if anybody wants to let me know. But I think this is one of the only ways that you can do this. I know that right now Intrepid is enabling companies to work with their older equipment with brand new ECUs that only talk in the AUTOSAR language. And AUTOSAR PDUs, they can be dynamic, right? They can, their transport layer can be produced on the fly. We could still gateway this automatically into CAN, CAT-FD, or Ethernet. So you got expensive tools that you want to use, and you've got a new unit, a new ECU that you want to test, and you don't want to wait. Talk to me, please, because I can show you this feature. It's fully functional now. It's just not integrated into Vehicle SPI 3 yet. So I'm more than happy to go into more detail about that. Okay, I'm going to open up the software real quick. So the Gateway Builder. The Gateway Builder is located in Embedded Tools and then Gateway Builder. So this is what it looks like. A lot of big empty space here before we do anything. So I did take some time ahead of this webinar for the sake of time of loading a database first. If you're unfamiliar, you do that in the network databases section in Vehicle SPI 3, which is in setup and network databases, among many other places, right? So there's a button here for it. Yeah, we make it pretty easy to get here because managing databases is a pretty big part of a lot of people's jobs. If you're using a protocol analyzer, you're probably working with databases on some level. So I loaded a database. Spoiler, it is a Formula SAE vehicles database, so nothing proprietary on the screen here. Don't think I'm showing you anything that you need to quickly jot down to so you don't have to reverse engineer it later. Nobody's driving this car except for the race car drivers. So we're gonna use that for this, but we did load this in here, and then I also loaded in an ARXML on the Ethernet side so that we have some decoding on that side. But here's the Gateway Builder. So like I said, on the left-hand side, this is the input networks. So if we open this up, these are message objects. So I can expand this even further, and then I get the signal objects that are on that message. So we're going to play with this engine broadcast 13 message. Looks like it's R/D5FD. So if I want to do a message gateway, all I've got to do is drag this across. Okay, now it's in the center, and then I get my setup panel down here at the bottom. So if I'm just looking to forward this message across onto the next network, I'm done. That was it. If I need to go the other way, I would still need to set up the other way. But if I'm literally just trying to take one message, take all of its signal contents, and then every time it's present on the bus, send it over to the other network, I'm done. It was drag and drop. That was it. If I want to map, it's going to ask me to select a message. So if I want to select a message here, I can open this up and I can select a message here and drag it down here into the message section. Now I'm gatewaying from one to the other. If you're unfamiliar with where these messages can be viewed, by the way, this is our messages editor. So if we go to SPI networks and then messages editor, it will open up this view here where we can view these message objects, and then down below the signal objects on each message. So anyways, back to the Gateway Builder. So that's a message gateway. If I want to delete that, I can just delete this. Remember, network gateways are another thing that is very easy. So if I just press the gateway entire network button up here, all it's going to do now is ask for my output network. So if I need to change that, I can just use this drop-down menu. Let's say I want to change it to dual wire CAN 4. I can change it to dual wire CAN 4, and I can hit set as output network. And then boom, now I've got an entire network forwarded from CAN 1 to CAN 4. Remember, if I need to change my input protocol, maybe I want to take these CAN frames and I want them to be CAN frames with bitrate switching. So maybe I know that my tool or my ECU on the other side, or my network on the other side supports CAN-FD and is actively using bitrate switch to change the baud rate of the data field in CAN-FD. I could do that or without BRS, and I'm done. That's gatewaying the entire network. It's very easy. So if I delete that one, let's see, and I want to do, say, a signal gateway, I can grab one signal and I can just drag that into the center as well. So it's going to ask me then what signal I want to gateway. So this is where I can show you kind of a trick in the messages editor. So for signal forwarding, right, I'm done. But let's say I want to map a signal to a specific message, but I don't have any messages defined, say, on dual wire CAN 4. Well, let's go over to the messages editor. I could filter here by my R/D. So what was it, 5FD, I believe? Yep, that was our engine broadcast. I'm going to do this. I'm just going to right click on this and I'm going to hit copy. And then I'm going to go to dual wire CAN 4. And I'm going to go to the receive section instead of the database section here and paste my message. So what is the difference there? So the database section shows you all of the objects that are in the database that we imported. So if I switch back to dual wire CAN 1, these are all literally pulled from my DBC file. I can click through, I can open this up. I can view scaling information. I can view offsets. So, here's some scaling on this signal. All of this is from my database. But as this is called the message editor, right? This provides a platform for us to edit everything that's in here, but Vehicle Supply 3 is not in the business of changing your DBCs. That would be bad. We do have ways that you can edit DBCs, but it's not something that you can just trip into here. So you don't have to worry about accidentally writing changes to your ARXML or writing changes to your DBC. That's what the receive section is for. So what I did was I went here and I copied my message on DWCAN1, and then we went to 4, and I pasted it into the receive section. So the receive section acts like a database section. So it's a platform or a section for message decoding information, right? So this is a definition for the message at R by D 5FD. But in this section, I can make changes. So just to show you, if I wanted to make a new signal, I could make a new signal and I could call it Matt's signal. And there it is. But anyways, a really important note about the messages editor is, so let's say I had pasted this into DWCAN1, and now we have the same message existing on receive and database. It's really important to note that the receive section always takes precedence over the database section. And that's because if something's there, you put it there and we assume you're meaning to use it. So do note that if you're adding a bunch of things in the messages editor, if you've got a duplicate, we honor receive first. So it's, if you've changed decoding in here, that might mean your data looking different, depending on what you're expecting to be using. So I pasted my signal in here. So if I go over to the gateway builder now, and I change this over to map, let's see here. Oops. Give me 1 sec. All right, and then I drag my oil pressure. Oops, I'm gonna change that. Bam. Now we're mapping one to the other. Remember, we can change our output triggers down here. So if I don't want to say, let's say I don't want to map this signal over until the signal actually changes. So maybe this was, like I said, a state encoded signal is a lot of times where this is needed. We could switch that over to change. The other thing I should mention that I don't think I mentioned earlier is, let's say instead of triggering on receive or change, I want to basically be using my gateway output network to sample what was being sent over from the input network. We could also click this use rate button, and that's going to transmit only using the message rate that's defined here. So you could define your rate in the messages editor by setting a default period here, or you can actually do this in what we call the TX panel if you build it in the transmit section. Or we can actually select this transmit only after the first trigger. So we can maybe set up a condition that we're waiting for, and then we can start transmitting it on a rate. We can also transmit only when it's full. So maybe we are only mapping signals when the data changes, but we don't actually want to send our message until every signal has a fresh value. I was asked to do that many times working in the support department. So I know that's a very common use case. So that's this option here. If you select this, you actually get a timeout as well. So let's say you're building a signal that has 20, or you're building a message that has 20 different signals that you're mapping over from different messages on one network. You don't want to necessarily wait indefinitely for something to fill. Like maybe signal 19 in there is not coming across for some reason. You don't want it to hold up necessarily everything else, so you could add a timeout, which can effectively act as a pseudo kind of rate then, if that message is never coming through. But it can guarantee then that your traffic is still coming out as you expect. All right. Let me hop back here. I'm going to jump to my last slide here. So I am quickly running out of time. I wanted to leave a couple seconds for questions if there were any. And then I wanted to mention also that you can reach out directly to me if what you saw here is something that you kind of want to work with or try. Maybe you don't have Vehicle Spy 3 now. You can definitely reach out to me and we could talk about that. And then one other thing I do want to mention, if you actually just want to come in and talk about gateways, we're actually hosting an event called the SDV Social on May 8th. This is at Intrepid. If you've never been to one of our events, we provide food, music, beer, and demos. Who doesn't like beer and in-vehicle networking technology? That's like my favorite combination. So please come and have one on us. But if you wanted to talk about gateways more or any other types of your testing or validation needs, by all means, come check us out at this event.
Thank you all again, and thank you, Matt.
Thanks, Jordan. Thanks, everybody.